Hi, everyone. Welcome again to our second workshop of the Secure Development Series. My name is Huichi. I lead the events here with OpenZeppelin. I'd like to start with giving a quick intro into OpenZeppelin, and I do see some familiar names from the first session, so please bear with me while I bring everyone to pace on who and what we are. OpenZeppelin is a security company. We build, inspect, and connect with products and services in the blockchain space to help us achieve our mission of protecting the open economy. We have three main offerings. Many of you may know us from our open source smart contract library. We offer audit services, and we built a product called Defender, which helps automate smart contract operations. Of course, we couldn't do this without an amazing team. I'd like to add that we are growing our team and that many roles are open, which you'll find on Zeppelin/join. That's zpl.in/join. So that's it from me. If you have any questions, please use the Q&A and we can go over them towards the end of the session. I do have Santiago Palladino, our lead dev, here on the call with us, so he'll be helping us answer some questions during the session. I'll leave you with Martin, our security researcher, who will lead this workshop on helping you learn the various strategies for secure access control. Thanks.
Bam. Hi, everyone. So nice to see you all here. So yeah, more than 50 people in the room. This is getting crowded. I'm so excited to have you all here and seeing so familiar faces and names. So it's so nice that you're here with us. I'm just going to share the presentation and we will get this started. Lots of contents for today. So grab a cup of coffee and get comfortable. So we are just going to start. As Huichi was saying, the idea for today is talking about strategies for secure access controls, which is a recurring topic in the security community. So with this session in particular, I want to share with you many of the insights that we have from a security background, and so you as developers can start coding things more securely, probably in your next projects. So many of you may have already joined the previous sessions that we did on the dangers of token integration. It was really, honestly, I think that it was an interesting session, lots of content in there. It's already on YouTube, you can watch it. It's free, it's open, it's there for you to review it and to learn from it. And today we are going to be talking about secure access controls, right? But as I was telling you in the previous one, this is a series, right? So we are covering specific topics, but at the same time, we are trying to build together a mindset towards security, right? So in this mindset, we want to be able to learn what are the right questions, what are the right approaches, the right triggers and intuitions that we should be having when we are trying to build secure systems. So that's what I will be like trying to bring up every now and then in the sessions, is that, okay, yeah, we are talking about the specifics, but there's also kind of a bigger picture in here about coding things securely. So hopefully with this ongoing series, I will be able to share and to share some of that paranoia with you all. So access controls, right? We have known this for a while. I won't dive too deep into this particular issue because, I mean, it's old, we all know about it. And if you don't know about it, you can go read about it. So we have had experiences around access controls, right? It's not something new, and it might be seen as a recurring source of problems. And you can even, in this slide, put many names on that X, right? We know of examples, won't be mentioning anyone in particular, but we know examples of projects that have failed in some sense at including or implementing the right access controls. And that means that, well, money got stolen, people lose their money, and so on. Many examples of that, you can read that online, you can see write-ups, vulnerability reports, audits, and so on. the idea of the session is looking a little bit forward into where the right strategies that people should be using today, so that, well, we don't always run into the same old issues, right? So one usual topic that comes up when we discuss access control is, well, some people might be building centralized systems, some people might be building more decentralized systems, and there is this sometimes kind of a tension between these two extremes, right? But I don't think that's the right discussion to have today. Honestly, I think that while we say we have DeFi, which we call like decentralized finance, I would say that we are actually decentralizing finance, right? So we haven't gotten to the point in which is fully decentralized, and probably some people don't even want to get there, right? So between decentralized and centralized, there's a huge spectrum, and both extremes also have value propositions and have reasons for existing. So my approach is usually more thinking about how do we go from centralized to decentralized, and thinking that it's a journey, right? So it's a journey in which we go through like a progressive decentralization approach that we can call it, in which, okay, it might be worth at the beginning if you are coming from a more traditional development background, not so much related to blockchain, in which, well, you might be used to thinking about centralized systems. And little by little, you can start understanding about the ethos of decentralization and why we are building on this ecosystem and what are the ultimate reasons and what's the utopia that we have. Always walking through this like progressive decentralization path. But in the meantime, we need to be able to like have consistent and reliable access controls, right? Me as an auditor, for example, as a security researcher, when I go into a code base that I'm not familiar with, I like to see consistent and reliable access controls, because it gives me kind of a sense of security in that people are actually thinking and actively thinking about these kind of things, and they don't take these kind of things lightly. And seeing consistency throughout multiple versions of a project, and not only multiple versions, but actually just between two different contracts, and seeing consistency in how access controls are implemented, and seeing them always implemented in the same way and in a secure and reliable way, it's super valuable for us auditors. So we are going to cover today strategies to actually accomplish that, and we are going to like cover specific examples of projects in mainnet and so on. So you have like a better idea of what the things that I'm talking about. Similar exercise to the one we did last time. I know that some people liked it, and we are going to be doing this over and over again. We have this piece of code. I'm going to give you between 60 and 90 seconds, so you can start thinking about problems, issues, in code smells, intuitions, questions that you might have. Imagine that you are code reviewing this particular example, and try to detect things. Try to see what kind of comments you would make about this code. Take local notes, write down on a piece of paper, whatever. You don't need to share that. It's just an exercise. There are no right or wrong answers. I mean, there's a huge spectrum of answers that we can come up with. So the idea is take the time, 60 seconds, and I will just shut up. let's do, I don't know, 20 seconds more, and then we come back. Okay, hopefully you read it line by line. For those of you who attended the previous one, you will see similar things in this piece of code. But before I jump into the actual triggers and things that I can share with you about this piece of code, and probably you can, in your own time, try to see where, which ones did you spot and which ones did you not, and what kind of questions you came up with. Similar to what I said last time, and this is one of the biggest things that I try to convey to you, is that we should be asking questions, right? And the code is presented to us as a source of truth, and we should be questioning that, right? The main mindset, I would say, or the core mindset that we as auditors can have, or code reviewers can have, is actually questioning the code, right? Many people actually go even to say that, okay, that code is law to some extent. Some have that opinion and repeat that as a mantra even. And we are so used to questioning the law and questioning to what's imposed to us. And so my idea is, well, let's do that similar mindset and let's question the code. Let's question what people are telling us that a piece of code does, and let's try to question that. Let's try to find ways in which that's not true. So that's the kind of the mindset that I want to share. Let's question the code. And you will hear me repeating this over and over again until you believe me. So some initial triggers, again, does it even compile? We covered this one the last time, but I'm not telling you what Solidity version this is. So depending on Solidity versions, we may have arithmetic problems in there. There are no doctrines, again, so what's this code even supposed to do? I know I'm repeating myself from the last time, but this is, again, a recurrent thing. If we don't know what a certain piece of code is supposed to do, how do we know what it should actually be doing, right? So how do I know that this is okay or accurate in the operations that it's doing if I don't know what's its intention in the first place? Then you see me like importing an ownable contract, but we didn't actually read the code for that ownable contract, right? You didn't read it. So you cannot make sure that what I'm telling you that ownable is doing, or what you're assuming that ownable is doing, is actually right. How do you know that, I know, an owner is actually being set, or how do you know that this ownable contract had this only owner modifier? I know in ownable we can find whatever thing. So we as code reviewers should also usually be inspecting those kind of dependencies, depending on whether, well, it's actually within a scope or out of scope and blah, blah, blah. But it's nice to think that part of the behaviors might be hidden or might be in another place and not in the specific code that we are seeing right now. Similar things to last time, like no visibility on static variables, no events, no error messages. Might those be problematic? I don't know, depending on where you are debugging it or where you are trying to come up with off-chain monitoring for the events. And if you don't have events, you won't be able to monitor the off-chain operations of this contract. So some things, right? So, and additionally, we are seeing like, okay, we have a low-level call, but the code is not actually checking the return value of that low-level call, and that might be problematic in some ways. Then what if, let's assume that the ownable contract works okay, right? So what if this owner authorizes itself? Could that be problematic? Is that intended? Is that not intended? Is there like a rug pulling scenario in here that we might be missing, and we as code reviewers should be kind of highlighting it at least? And most importantly, and the main trigger of the talk, is who controls that, right? What's behind that only owner thing that is supposed to be authorized in account so they can remove Ether probably from this contract? So what's that privileged account look like? Is it an EOA, is it a multi-sig, is it a governance system? Is it, I know, many things could be hiding in there, and we should be thinking about that. And that's the trigger for the talk. So there are more questions even like that we can start asking, right? Behind that only owner, again, private key, multi-sig, is there a governance system? Is it open? Is it limited? Perhaps it's another contract on the system. Does that private key or multi-sig or governance have other roles in the same system? Because if one gets compromised, can it affect other parts of the system? Is there a time lock mechanism behind it? And we're going to cover time locks today and how those work and what's the intention behind them. Even more questions like beyond smart contract security, right? Because we all know probably that security goes well beyond Solidity code. We should be, perhaps, if we are building a similar system, we should be thinking about, well, how are those private keys stored? Are there any backups? Who's got access to them? Is the operations executed? Are the operations executed with those private keys actually logged or monitored or even audited in some sense? How are those keys generated? Because we have seen in the previous weeks, if you have been like reading on security incidents, that there have been some problems in creating private keys and signing transactions and ways of recording private keys from the same transactions. So thinking about that usually might trigger different attack vectors. Again, some things might be out of scope of our reviews, some things might not, but these are just kind of questions and triggers that we can think about. So I'm having some troubles with, okay, ownership. We know a little bit about ownership, right? So we all know about ownable probably. We have this only owner. It's basically a way of controlling who has access to a certain function in a contract. In OpenZeppelin contracts, we have the ownable contract that you can inherit from and include this functionality in your contracts, blah, 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 right? So the usual story, we won't cover this too much because it's like the usual. If you don't even want to use OpenZeppelin contracts for your reasons, you can see other similar implementations, such as in DAppHub, you will find like this DS of a contract in which you have like this set owner function, and you will have the contract will have an owner, and this owner can execute different functions on the contract. That these functions will be marked with this auth modifier. And if you are familiar with the maker code base, you will see this pattern in some places at least. And something interesting is that in this contract, you can actually set kind of an authority contract that you can call, and you can actually have like finer grained controls in ownership, because you can actually decide where to allow access or not to a functionality depending on who's the caller, and not only that, but also what function is it actually calling. And you can extract that functionality to an authority contract that you can query. So this contract also provides that kind of functionality. Moving on, yeah, my click is having some trouble, sorry about that. It's fine to use only owner. It's just a matter sometimes of documenting their powers and being transparent with your community, right? So this is a contract from Optimism, and you will see like the ownable pattern being used, and they have like this registry of contracts that an owner can change contracts in them. And you will see that in USDC also, and you will see that in Chainlink contracts as well, and in many others in the community, right? So many people are using this pattern. It's very well known. It's okay to use it. It's fine. As long as I think that you are transparent with it, you document your roles and the powers of them, I would say it's perfectly fine. And behind an only owner, what can we have, right? So we can have an EOA, and that EOA might be controlled by a MetaMask account, or could be controlled by some keys stored in a cold storage wallet, or even like you can have like a defender relay that signs the transactions and is able to interact with sensitive functions as well, right? And you can get fancy, like you can have multiple EOAs talking with a like only owners pattern, and not even EOAs, like you can even have like contracts and a multi-sig, which is usually today, the multi-sig is quite often the pattern that we can see. And actually you can wrap that, handle that multi-sig within the Defender product of OpenZeppelin. It's called Defender Admin. It's a module of Defender, and it will give you like a super beautiful UX, honestly, to handle multi-sigs. You can actually create proposals, and you can see actually like the strategies that you're using for those multi-sigs. It's honestly Really, really nice, and you can check it out. It's open and you can sign up. So this multisig pattern is probably the most well-known one and used throughout the ecosystem today. Just an example of that, I mean, in price feeds of Chainlink, we have this multisig controlling many of the price feeds and some parameters in them. And if you're interested in price oracles and these particular behaviors of price oracles that you might not be so familiar with, next session we will be covering the dangers of price oracles. So I hope to see you there as well. This is just kind of a little spoiler, and we can actually see then what that multisig can do. So roles. Moving a little bit beyond ownership. Sometimes you want to have roles because you might want to differentiate sensitive actions within your contracts and have different levels of authorization. So roles can be useful, add readability to the code, and it's easier to reason about a system with multiple levels of authorization if you clearly define what the roles are in there. So let's say that we have a mintable token that can be paused and upgraded, and depending on what you want to do, you might have somebody do everything and some people doing other things, right? But actually in the Ethereum ecosystem, this is kind of a little bit different. We actually have like food name mintable tokens. These tokens probably won't last too long. It might be upgradable, it might be pausable, and you might have, I don't know, a Twitter user with a gorilla picture in the profile that can do everything, or a cat and a monkey upgrade and mint, or a duck dog and a cat upgrade, posting and minting. Depending on what you want to do, you can choose your own adventure, and it's perfectly fine. So how do you do this? In OpenZeppelin contracts, we have this access control utility that you can inherit from, and it's there, and it's open, and it's free. And I honestly, I don't know if there are many excuses not to be using this today. In access control, you will find functionality to manage roles, to be able to mark functions with this only role modifier. So you can, for instance, you have like an only minter thing. So you have the only role is the minter, or an upgrader, or a burner, or whatever role that you want to define. And you have even like included events that will be triggered, for instance, when a role changes. And you can monitor that, and you can include the monitoring and sentinels in OpenZeppelin Defender to monitor the changes in the access control contracts that you're implementing. And this is mostly out of the box. So quite impressive in my opinion, and it's there and you can use it. And it looks this way, right? So I have a question for you, and we will do a quick poll. First time I do a poll on Zoom, so bear with me, hopefully this works. My question will be, how long does it take to code? It must be secure, right? So you cannot do anything. So it must be secure at least. A secure, upgradable, mintable, ERC721. Don't drop your answers in the chat. I will just open a poll now. Bear with me. This contract should have role-based access controls. And again, must be secure. You cannot code something too quickly. You should be thinking about it. And it should have these features, right? So let's say for the average Solidity developer, we will do a poll, and you can tell me how long do you think, like for the average Solidity developer, would take to code a contract like this. So let's see if I can run the poll now. The poll should be running for the average Solidity developer, right? Remember, must be secure, must be tested, should be upgradable, should be mintable, should have secure access controls. Questions coming in. A couple of more seconds. Anybody else wants to answer? Let's see if the crowd is wisdom or not. Okay, let's send the poll now. We'll show the results, and you should be seeing the results now. So the crowd is saying that, okay, 40% of the people in here think that this would take to be coded around 1 to 5 days. 22 is saying more than 5 days, and a huge number, 35%, is saying less than a day. So let me try that, actually. Let me see if I can actually do it now. It must be, I'm saying that it must be upgradable, it must be mintable. So let's see. Wait, Zoom is getting in the middle. So I'm going to go to contracts wizard, wizard.openzeppelin.com, and I'm saying that I should be coding an ERC 721. Okay, I told you that it should be mintable. I told you that it should be upgradable. I told you yes. So let's do upgradability, and let's get fancy and do UPS kind of upgradability if you want to, or you can do transparent as you wish. Let's do transparent perhaps. And we should have roles, right? So let's do roles. And let's put it a fancy name, right? Because we need people to actually buy this kind of thing. So fancy name and FNT, the fancy name token. Mintable, upgradable, and role-based access control. And this is done. You can copy this, you can take this to Remix, you can download it. And I would say it's mostly ready for deployment, honestly. And this is all built with secure contracts from OpenZeppelin contracts, just 3 clicks, and you can actually do this. You want to make it possible, we make it possible, right? And so on and so forth. My recommendation, check out Wizard, is awesome. So yeah, that's Wizard, right? So I know many people in the audience might be, if I took a picture of the audience in this case, it would be something like this. Some people might be amused, right? I know that, but others, okay, this security researcher actually knows how to code. So Zeppelin Wizard is Zeppelin Wizard is there for you, and you can actually use it and implement contracts with secure access controls right from a click. Incredible. So let's continue. My click. Okay. Yes, it's fine to use roles. You should be at least documenting the powers, being transparent with your community about them. Let's see examples of people using roles. This is Compound, right? We have in Compound a unit roller contract, which is a proxy and like a core contract of the system, and the controller, which is the implementation. And talking with this pair of proxy and implementation, we have a community multisig, a time lock, and an EOA. And behind the time lock, we have a governance system, right? This is from a very high level overview. And we see roles even, like we see a borrow cap guardian, we see an admin, we see a post guardian, and so on. So it's fine to use role, and people are actually using. And if you go to their code, you will see, like you can read about these roles, and you will see admin, and you will see borrow cap guardian, and you will see post guardian, and people are actually using these kind of roles today. I've been talking with developers, and they have told me that, well, roles are fine, might be useful, but you should be careful with them. And there is some truth to this, in that too many roles might be too difficult to manage and might be difficult to coordinate actions. But on the other side of the coin, you might say, well, if you have too few roles, it might be dangerous to have like super powerful accounts in your system, because it might be the case that an account gets compromised, the keys get compromised, and at the end of the day, the entire system is compromised. So there is a, you should be thinking about striking a balance between too many and too few. I don't think there is a silver bullet, honestly. It's just a matter of discussing with your team, discussing with your community, and seeing what works best for you. Moving on a little bit, it's time locks. Time locks is a cool mechanism when we are talking about access controls. And so far, I've been telling you that, well, there might be privileged accounts executing actions on a system. And those actions so far are just instant, right? So we are not giving time for people to react. And it might be the case that we need to give people time to react to something. We want to be kind with our community and with our users. So we want to give users time to react. We want to allow time-delayed opt-out changes in many cases. In many cases, we may not want that, but there are use cases for this kind of mechanisms. So how would this look like? We have a time lock. that sits between something, we will cover that something later, and a contract that we are trying to control, right? So this something will queue an action, for example, on the time lock, and after a few days, for example, the time lock will be able to trigger an action on this contract that is controlling. Yes, the question would be, okay, Tincho, but who owns the time lock, right? We will see that. And actually also to note that the time lock will be needing access controls as well. Very well. We will go into that a little bit. But how long does it take to code a time lock contract? Okay, because it's perhaps this kind of fancy mechanism that is sitting in the middle here and has these capabilities of queuing things and canceling things and executing things. But we are not going to make a poll because you don't need to code your time lock. You can actually use the time lock that is included in OpenZeppelin contracts. It's there, you can use it, and it will look something like this. You will have like different roles in the time lock. You will have an admin, you will have a proposer, you will have something that can execute things. You will have like an adjustable delay in your time lock, and this time lock would be owning some other contract in your system. And that means that you can divide these roles into the accounts that you want, but these roles are there, and you can go to the documentation and read more about it. And honestly, as I showed you before, there are projects already using time locks, and there are use cases for them. And I think that soon we will start seeing more and more traction into this kind of clever mechanisms. And it's fine to use them. I showed you before, there is a time locking compound, for example, and if you have ever seen the compound governance, you will see that there is a step in which is called queued. I'm using compound just as an example because I think that their system is kind of easy to understand. It's complex enough so that it's interesting, and it's simple enough so that I can show it to you in a slide. Some other governance mechanisms are quite more convoluted, and their variable names are not that easy to read. So we in the governance systems of compound, if you are went to the UI, you will see like at some point the action is queued, right? So that means that some action got queued into the time lock itself. And going a little bit deeper into this particular time lock, you will see a nice mechanism to some extent. First of all, they are using this kind of offer accept pattern in which you don't want ever for the admin of the time lock to be bricked, for example. So you're first offering the admin, and then somebody comes and picks that admin up. And more interestingly also is that some parameters in the time lock can be changed by the time lock itself. That means that the changes to the time lock will be going through a time lock and be time locked. So that's interesting, and that's a mechanism that you can use. It's easier to see, perhaps, to explain, but probably you understood what I tried to say. So there are other projects implementing time locks. In this case, we have a contract from DAppHub as well, which is called pause, and you will see it used in Maker. That similar to what I just showed you, right? You can queue, you can cancel, you can execute actions, and you will see them marked with this auth modifier, right? Because there will be kind of an owner or somebody with privileges to queue and cancel, in this case, actions in the time lock. And then we have, like, in this case, the execute function that anybody can call, because the action was already queued and it's already kind of approved. It's just a matter of executing it. If you want more documentation, you have links over there. Fine locks are time. Fine locks are time. Time locks are fine, but you might need to bypass them, right? The reality is there are actions in your systems that might be too sensitive, or you need to execute them too quickly to go through a time lock. They cannot wait for 2 days. Let's say that you need to stop everything because somebody's hacking your system, or to roll out a quick fix because you found like a huge bug that might open up a huge attack vector. So it might be a case that you need to bypass time locks, and that can be done as well. I showed you that before, actually. You can have like a community multisig, such as in this case, and an EOA, and different roles that may be able to bypass the time lock, and that is perfectly fine. People are actually using it. And most interesting is you may have even like a governance system, and the governance system is in charge of choosing who's owning or who's holding these powers, right? So your community can be okay and say, well, I want you as a developer of the system to hold the powers of a post guardian in my system. And that is perfectly fine. And the governance can actually choose that. They can make kind of an informed decision around it, and you can be transparent and share that with them. And being able to say, well, I may be able to bypass the time lock, and that can be fine. More details into the link in there. I've been talking about governance, so probably we should be saying something more about governance, right? So let's do that now. Because at some point we want to, perhaps some projects might want to delegate kind of the privileged actions in their system to a more open governance system. And honestly, from what I have seen, and this might not be true in all cases, but from my experience auditing governance systems, usually the most complex part are on the implementation side. Sorry, on the mechanism design part, and not so much on the actual implementation. And what I mean by that is the Solidity code, once you go read it, might not be too convoluted. It's kind of straightforward. Usually, if you're kind of reviewing a rather simple governance system, but it's far more interesting to think about what are the mechanisms behind that, how's the community interacting with that, whether there is a token or not, what's the value of that, who's willing to participate, and so on and so forth. So complexity usually will fall not so much on the implementation side. And talking about mechanism design and incentives, we have seen cases of some weaknesses and even vulnerabilities in some of them. You might have seen this post by Mika Soltu, like a researcher at some years ago, like highlighting some weaknesses in his perspective in the Maker system, and also a recent, somewhat recent vulnerability. It wasn't a vulnerability, I would say an attack, but I don't even know if to call it an attack, in a project where some attacker bought governance tokens. They were able to gather most of the majority tokens that they needed, and they executed a vote in the governance systems, and they took over the system and they kind of attacked the system. I don't know, because they just bought the tokens. So again, like usually the design and the incentives behind governance systems can be a little bit more complicated than the actual implementations. So for those who are not that familiar with this kind of implementations, we are always talking about kind of a contract that is allowed to execute sensitive actions on others. That means that these others will have access controls and will only allow calls from a governance module. People will be able to propose actions and vote on this contract. The actions will only be executed once they are approved. This execution can be instant or can be delayed, such as if we include it in a time block, for example. And usually there will be some kind of governance token involved, right? So, and we know about this in the community, Comp, Uni, Maker, and many other governance tokens. Sorry if I'm not mentioning your favorite one. But honestly, it's kind of something that is becoming increasingly popular, and I would say common to see. So one common implementation of governance protocols, sort of governance systems or modules, is the Governor Alpha contract that you might have heard about. This was actually the one used by Compound in the early days. Now Compound has moved to another one, and if you have seen the governance system module by Uniswap, is actually using a modified version of the original Governor Alpha, where you will find governance users and you will find a guardian. And actually this guardian, you won't find it in Uniswap. It was only in the early versions of the Compound governance, in which this governor will actually be owning a time lock and will be able to queue and propose actions in this time lock. This guardian had the power of, first of all, abdicating, but also changing who's the admin, and also canceling proposals. If you go to the code of the Governor Alpha, you will find these roles, right? So you will find a function for abdicating, you will find a function for canceling, and so on. And you will find like the guardian role mentioned in many parts. Then this move to the governor Bravo. In Bravo, it's a little bit fancier, but I wouldn't say too much complicated. Only that it's upgradable, first of all. So actually, if you read the governor Bravo contracts, you will find like delegator and delegate. A simple proxy upgradability, nothing too fancy, honestly. But also we have like governance users and this admin role. The admin has powers to upgrade, to transfer its powers, and also setting voting periods and other parameters of the governance. But it's interesting to know that this admin actually is the time lock itself, right? So the changes to the governance itself, this is at least last time I checked, right? A couple of days ago, this can change. But last time I checked, the changes to governance itself are delayed and are opt-out. So that means that changes to governance itself will be queued through a time lock, and you will have time to react to changes in the governance itself, which is quite neat, and it's quite a clever way of implementing a cool strategy for access control in some other contracts that are the actual contracts of Compound or Uniswap and so on. So it's a nice strategy, I would say. I should have mentioned in this slide, you can see in the Governor Bravo, you will see, if you read the code, it's open, you can read it, and you will see this admin being mentioned a couple of times. And governance is coming to OpenZeppelin contracts. This is at least a huge or very important to me, probably for the community as well. I hope that people start using these contracts once they reach a stable version. They are already merged in master. You will find it there, and you can start playing around with them and provide the team with feedback. That would be super welcoming, obviously. But it is not still on the stable version of OpenZeppelin contracts. Very, very soon, and stay tuned for more news about that. But we will have like a dedicated governance module in OpenZeppelin contracts based on these governance alpha and Bravo contracts that I showed you before. Some additional comments on governance. Guardians can help in that they are this, I mean, guardians by like privileged accounts, right? So they can push some proposals, for example, if there is no kind of active community participation. Because again, in governance, we are usually assuming that, well, people will participate, but what if nobody cares? And there should be perhaps some guardian pushing for proposals. And also trying to stop if at some point there is kind of a proposal with a malicious intent or something fishy going on, a guardian may have the powers to stop that. Another thing to consider is talking about lack of participation sometimes, or not even because people don't want to, but it might be expensive. It might be a case that you need to consider delegation mechanisms so that people participate and this governance mechanism can move forward. And also make sure that, well, I'm saying that governance can be a nice strategy for access controls, meaning that the governance will be kind of able to execute sensitive actions on your system, but beware that if governance can execute any action in your system, and you don't have checklists or off-chain validations or documentations or trying to share with your community how the process should look like, it might be the case that your system is completely broken after a governance upgrade, for example. And there are projects out in the wild that function in that way, that, well, governance has totally full control, you can do whatever they want, and the wisdom of the crowds will tell. But it might be a case that you need to set up kind of, again, documentation, checklist, off-chain validations, scripts, something for your community to use. Otherwise, they might not be aware of certain technicalities of your protocol, and they might end up, not because of they are having malicious intent, right? Just because they don't know about some weird solidity thing, for example, and they might end up proposing and executing something that is actually not so good for the protocol. So be aware of that. And usually in governance, there is a governance token, right? So remember that if you're having a governance token, tokens can be flash loaned, and you should be protecting against it. And one strategy to do that is not measuring voting power at the current block, and that's why you will see, such as in these common governance systems, such as in Uniswap and Compound, and probably many others. Again, these are just examples, simple examples to prove my point, is that you will see that these governance tokens have this get prior, have a way to query the balance of an account in previous blocks. It's using kind of a clever mechanism of balance snapshots and so on. And actually, we have an OpenZeppelin contracts an ERC20 votes extension of the ERC20 standard that you can use. And it's there, and you can have like your own governance token with this exact functionality. So the idea is, well, I don't want to know what's your current balance in this block, because you might have taken a flash loan, and you might kind of trying to be tricking the governance system. So these contracts will just query what was the token balance in the previous block. So that way you are kind of protecting your governance systems against this kind of attack. And again, it's kind of yet another step that you can take for more robust access control strategies. So we are reaching the end. It's been kind of a packed session, honestly. Lots of content. I don't know if you were aware of lots of that. I know that sometimes I cover things from a more high-level view, but the idea is to offer you with information that you can then go and read the details and try to implement that into your systems. But some closing thoughts around this. So we have been talking about consistent and reliable access controls, and that is fundamental. I mentioned that at the beginning. We mentioned also the progressive decentralization approach and how important it is to share that with the community and being open about it. And if you have seen, you have been following developments of multiple projects in the space, they have been taking this approach. And I think that it's kind of a safe one, but also really interesting. You should be documenting all the roles in your system. Again, it doesn't make sense if you are not sharing with auditors, with code reviewers, with contributors, with users, with the broader community, who has powers in your system, right? You want to be transparent about it, and you want to say, well, yeah, I'm holding the keys for executing A, B, and C, but my plan is to remove that, or my plan is to still have that in the upcoming years, and I'm taking this step to protect those keys and so on. I mean, it's fine to have this, but we want to be documenting that. It will make like everyone's lives easier. We should be taking, I show you during the presentation multiple examples of building blocks that you can use to implement very different strategies for access controls, from simple EOAs to multi-sigs, to multiple accounts with 2 roles, to time locks, to governance, and so on and so forth. And there are building blocks that you can start using today. You should no longer be building even these kind of things from scratch. I mean, if you are trying to go for full efficiency and making something really, really clever, perhaps yes, you will need to write this from scratch. But most of the cases, I would say, these contracts are there and you can use them right from the start. One additional comment on top of that is that we might be having the best building blocks and the most secure building blocks, and let's say that the door to your house might be the most secure one, but if you don't share the key with everyone, it doesn't make sense, right? So let's also be mindful of that. Let's remember that private keys are a sensitive thing, and we should be taking good care of those and being able to implement the right mechanisms to keep them safe. Again, you might be using the very right components, but then if your off-chain handling of these keys is not the best one, it might get complicated. Last, learning from others, starting small, starting focus on what matters. I think that these are recurrent things that I've been telling you during this series. You want to learn more, you can take a screenshot now, otherwise I will share the slides with you all. These are some links on how and where you can learn more about access controls. Hope you have taken the screenshot. So moving on. Today we have covered these strategies for secure access controls. Stay tuned, because in 3 weeks we will be talking about the dangers of price oracles. honestly, one of my favorite topics of this series. And I think that it will be rather interesting to watch and to learn from that. We can share many things about that. I won't spoil anything else. In the meantime, there is OpenZeppelin Defender Advisor. This is a knowledge base of lots of security-related material that you can start reading. And many people within OpenZeppelin and now also outside OpenZeppelin have contributed to it. And honestly, it's one of the, I would say, most often overlooked resources in the community, and I would say that it's awesome. So my honest suggestion is check it out and see if you agree with me. What else do I have? Well, we are hiding. If anything of this talk rang a bell in you, if you felt interested, if you are feeling like you want to contribute, building secure systems, and thinking about these kind of things, we have multiple roles open at OpenZeppelin. Our link shortener is pretty cool as well. You have it in there. But honestly, we have these roles open. You can apply for them. Don't matter too much if you don't meet every single requirement. Honestly, we just want like people that want to contribute to a space, and you will find like descriptions in the links and so on. So hopefully we will see many of the people in this talk. We are 66 in this room already, applying for these roles that we had open. Having said that, I think that's all, folks. Thank you very, very much for staying with me. I enjoy this kind of series, this kind of sessions. Hopefully they are insightful and they are helpful for you. Hopefully they you can take some of these insights and you can start building more secure systems, and we can make Ethereum more secure and a better place for everyone. We want this technology to succeed, and security is fundamental for that. So let's build more securely. Thank you very much. Resources in there, links. I will share the slides later. You have my email. You can ping me on Twitter. I mean, that's the only social media platform that I'm on. So that's it. Probably we'll have questions, comments, and thoughts. But again, thank you very much for joining us.